In this video, I will be explaining the programming aspect of multiple linear regression modeling. In my previous videos, I have explained the theoretical portion or theory and mathematics behind the multiple linear regression. So, in this video, I will be explaining how the multiple linear regression model is built. There are many ways to implement multiple linear regression models, and in this video I will be explaining three different ways. The first way, what I am calling it as implementing multiple linear regression through various matrix operation that I have explained in my previous video. So here I have uploaded the I will show how to upload the data set from my local computer, and here this is the file that I am using as the data set for this particular multiple linear regression, building a multiple linear regression model. And here I have imported all the modules that are required to process the data. Typically we require pandas library, then numpy library. Here, because we are using one of the way to implement multiple linear regression is through OLS method, that is the linear ordinary least square method, and this method has been implemented in the Python StatsModel API. So that's why I have imported this model. Then to visualize the data we require seaborn and matplot, and we require to use some mathematical functions. That's why I have imported the math file. Now first operation, that let us upload the data set in our as a pandas data frame, and for that I have using this code which I have already typed it. And so this is the path of the file. Here you can, because I have received some comment, some uh, request how to use and how to copy the file path in Colab. So that's why I am showing this operation. You can copy the file path here by right click here and then copy path, and then you can paste here. That is PD read CSV method. The read CSV method from the pandas data frame helps us to load the data set and read it as the data frame. So this is the header of the our data set. So there is some error because I have not executed this code. So that's why that error come. Now I have executed this code. That is all the necessary files has been imported. Now I will run this code. So this is the header of the our file. There are four different vectors are there. Attendance, mid-semester examination mark, and here the HRS stands for the number of hours that a student spends before the day of examination while for studying the particular course or the subject. And end semester examination mark. Here we are trying to predict the end semester examination marks from these three different input or independent variables, that we are calling it as the attendance, mid-semester examination, and the hours spent while studying the course day before the examination. So this is the header of the file. Now let us describe the data set. Means the describe the data frame. By describing the data frame, we will know various centrality measures, centrality measures like mean, average, and like that. So these are the all the data, all these four variables, that's attendance, mid-semester examination, hours, and are numeric data, and that's why it has shown the average value, standard deviation, minimum, maximum, first quartile, second quartile, and so on. Now, before proceeding to implement the ordinary least square method, we are going to perform the correlation analysis. The correlation analysis is needed to be performed whenever you are going to implement uh, multiple linear regression model, because it will show you, it will help you to understand, um, it will help you to understand the it will help you to understand the how different input variables are related with each other. So this is the code for that. Here the CORR method, or the correlation method, helps you to perform the correlation analysis. And this is the output of this method is displayed using the correlation matrix. And this correlation matrix is interpreted like this. Suppose that if you want to check the correlationship between the attendance, this is attendance is our one of the input variable, and end semester examination, that is the column, it has the reading 0 point minus 0.10, means that it has the negative correlationship, and the strength between the correlationship is very weak. Normally correlation higher than the 7 is considered as the strong correlation. Similarly, the mid semester examination marks and the end semester examination marks, the correlation is positive and it has the value 0.75. The correlationship between the hours and the end semester mark is positive, but again it is the weak correlation, that is 0.25. Our purpose is to demonstrate the method, not to select one particular feature vector for the multiple linear regression modeling. Ideally, such the multiple in the multiple while you are building the multiple linear regression models, after performing the correlation analysis, if some major features has low correlation, then you can neglect from building the neglect or delete those features from building process or from model building process. But here I would like to explain the method of building. That's why I am not deleting those features. Now here I am the next step is to separate the input vectors from the output vectors, and here the our output vector is the end semester examination marks. Here I have separated out the output vector from the data frame, and I have labeled it as the end dog. Similarly, I have separated the input features from the data frame called mid semester examination attendance and hours, and I have added one constant vector which is necessary because while building the multiple linear regression model, it represents the unit coefficient of our first intercept, that is the beta 0. So this is the one column that we have added, and this is the mid semester examination attendance and hours. So there are four different columns are there for input processing. These are the called the constant, mid semester examination, attendance, and the hours. Constant is the coefficient for the beta 0. Then the next step that we are going to do is, now we are going to implement our ordinary least square method using OLS formula. That if you remember, the first step is that we need to transpose the input vector or the input matrix. This is now our input matrix. It has 73 rows and the 4 columns. See here there are 73 rows are there, and these are the 4 columns. Now this 73 by 4 matrix is transposed first. Here, before transposing those, that now this is available in the as a data frame. That data frame needs to be transformed or converted into the numpy array, and this is the method that you can call it on the data frame, that is toNumpy. ToNumpy is the method to convert or transform a data frame into the numpy array. And on the numpy array, you can perform the operation like matrix operations. On the data frame, you can perform the operations like querying retrieving data. Those operations you can perform on the data frame. On data frame, you can perform the operation like multiplication of the data frame, the transpose of data frame. Those operations are not supported by the data frame. That's why we needed to convert it into the array. And here we have converted the our input vector to numpy array, and we are denoting it as the x, and output vector we are denoting it as the y and converted it into the numpy array. Then the third step that we are going to do is that we are taking the transpose of our input matrix. Our input matrix is now denoted by x variable. Now there is from the numpy array or from the numpy library, there is one method called transpose, and which takes the input as the numpy array, and that numpy array is transposed by this method. Now here s1xt is the variable which stores the transpose of that matrix. After executing this, you will get the transpose matrix. Now there are 72 columns are there and 4 rows are there in this vector. So this is the our transposed matrix, which was earlier 73 by 4 columns. Now it has 4 rows and the 73 columns. Now after transposing, we need to multiply this with our input vector. So that is our second step. Now the output of the first step is multiplied with the second step or the input vector. So here output of the first S1. Now the output of the in the NumPy library there is one method called matmul. Matmul method performs the matrix multiplication operation. S1xt is our variable which stores the output of our previous step. Now that output of the first step is multiplied with the input vector, and that we are that first multiplication we are going to store as the s2 mul1, and this variable stands for that s2 is the second step and mul1 means that first multiplication. Now after performing this multiplication, our output of the second step is like this. So this has the 4 rows and 4 columns. Now the next step is to take the inverse of this. Now the inverse of this is done. There is one method is there available in the NumPy which converts the takes the inverse. Now see here np lin algorithm dot linear algebra dot inverse is the method which can which perform the inverse operation on a given matrix, and s2 mul1 is our previous output of the previous step, and we need to convert its we need to find the inverse of this. So you can find the inverse of this. So this is the inverse matrix. Now after taking the inverse, we need to multiply it with our transpose now. So that is our fourth step, and this is the fourth step. Here I have multiplied it. S1xt is our transpose and S3 inverse is this inverse. After multiplication, you will get this matrix. See. Okay. Now once you did this operation, fourth operation, in the fifth operation you will get the result. The fifth operation is again the matrix multiplication operation. In which we are multiplying our output of the fourth stage into the output vector, that is here see y. Y is our output vector or the output variable. When you multiply this, you will get the final output. Now see, this is our the final output or the estimated beta parameters. The first one is the beta 0, and here you check that 3.11 into 10 to the power of 1 means 31.1. and this is our beta 0. This is our beta 0. This is our beta 1. This is our beta 2, and this is our beta 3. Now it will have the beta 0, 1, beta 0, beta 0, beta 1, beta 2, beta 3, because our we are building the model out of 4 different variables, that is constant, mid-semester examination mark, attendance, and the hours. So these are the different coefficients that we have calculated using our matrix operation. So this is the first way in which you can implement the multiple linear regression model. Now the same method you can implement using the stats model, OLS method from the stats model that we have already seen in our while building the simple linear regression model. This is now I am explaining the second method. In the second method, I am using the OLS method, which is very simple. In the previous step, we require to perform the matrix operation, but this means there is only one single method out of which you can find build the linear regression model. OLS method is from the SM stats model, and it takes two different parameters, ndog and the xog. Xog is our input feature vector, and ndog is our output feature vectors. See here we have this separated out from our data frame. This step in the see here we have separated it. Here in this here we have separated it. So now after separating those, when we run this model, the model is built, and see here. Now here these are the different coefficients that we got. 31.15, 1.57 for the mid-semester examination mark, minus 0.216, and 0.14. If you compare these coefficients with the previous coefficient that we have calculated using matrix multiplication operation, we both are equal. See, 31.15 multiplied by 10 to 31.1, 31.11 here. MSC's coefficient is 1.57. Here one MSC's coefficient is 1.57. Now here the third coefficient is minus 2.15 into 10 to the power of minus 2. Check it. Now here you will get C minus 0.02, and here 0.1413 is the coefficient for hours. Here also 1.14. So both gets the more or less the same result. Yes, so that's why both methods implement the ordinary least square methods. Now what we are going to do is that we are going to implement the third method. The third way of implementing the method is from the uh, ScikitLearn library or the Scikit library. See, here I have imported the Scikit library. Then I have separated X from 3 columns, and MSC from the Y in Y is my output vector. Then here I have created one instance of linear regression class. Then I applied the fit method on that LM object by giving my input feature vector and the output feature vector. When I run this code, I will get the coefficients again, which are same. This is my beta 1, this is my beta 2, and this is my beta 3. Check it. 1.57 minus 0.021 and 0.143. So both produces the same result. If I want to calculate know the value of intercept. So the value of intercept is this much. Yes, value of intercept is same. So these are the three different methods using which you can implement a multiple linear regression model. The first method by using stepwise method of matrix based OLS method. Second is using OLS method from the stats model, and third is using linear regression model from the scikit module. So these are three different ways in which you can implement multiple linear regression model in Python. Thank you.